Okay, so when I say cybersecurity AI, what pops into your head? Probably some kind of super tough bodyguard, right? Programmed to protect one specific place, no matter what. But what happens when that bodyguard has to protect a brand new building they've never seen before? Well, they're pretty much useless. Today, we're going to talk about a whole new kind of AI, one that's less like a rigid bodyguard and more like a brilliant detective who can walk onto any crime scene and figure it out.
And that really gets to the heart of the problem, the big question we're tackling in this explainer. What is the fatal flaw in all our current AI guardians? Why do they seem so powerful one minute and then completely fall apart the second the environment changes? The answer, it turns out, points to a huge problem in how we've been building our digital defenses from the ground up.
You see, the core issue, when you boil it all down, is that we've been building a whole lot of one-trick ponies. These AIs are amazing at their one trick, defending one very specific network. But you ask them to do anything else and, well, it's not pretty.
Let's go back to that bodyguard idea. Imagine an elite bodyguard who has spent years memorizing every single corner, every hallway, every camera, every single entry point of one building. They are an absolute master of that one space. But if you take them and drop them into a new building across town, one with a totally different layout or size, they're completely lost. They have to go all the way back to the academy and retrain from scratch. That's our AI today.
This chart really lays it all out. On the left, you've got today's AI. It just memorizes layouts, which means it needs to be retrained for any little change, making it super brittle and inflexible. But on the right, that's the dream. An AI that doesn't just memorize, it understands. It can adapt on the fly, making it resilient and flexible. So the big question is, how do we get from the left side to the right?
Well, the answer might be a totally new approach called TERLA. Now that stands for Topological Extensions for Reinforcement Agents, which is a mouthful. So let's just think of it as the super adapter. It's basically a set of special add-ons that gives a normal AI brain a kind of superpower.
To really get why TERLA is so cool, you have to see the old way of doing things. This is a traditional AI model. It gets fed this massive, rigid chunk of raw data, the observation. And all of its internal wiring is custom built for that exact size and shape of data. It then tries to spit out a plan, a policy. But if the network changes even a little bit, the observation data changes shape, and the whole model just breaks.
And this is where TERLA does something brilliant. Instead of just jamming all that raw, messy data into the AI's brain, it has a clever first step. It takes all that info and turns it into a simple, smart map. It uses something called a graph neural network to see the relationships between things. This computer is connected to that server, which is part of this bigger group. It creates this flexible, easy-to-read map of the situation, and it doesn't matter how big or small the network is.
Okay, so this diagram shows the whole magic trick. On the far left, you have all that messy observation data coming in. TERLA's special extensions kick in and convert it into that clean, simple smart map, a summary that's always the same size. Then, and only then, does it hand that perfect map over to a standard AI brain to do the thinking part, the policy learning, which is just a fancy way of saying deciding what to do. And here's the kicker. Because that map is always in the same simple format, the core AI never needs to be retrained. It can suddenly understand any network you throw at it. So this all sounds fantastic on paper, right? But does it actually work in a real fight? To find out, researchers threw TERLA into the ultimate test, a seriously complex cyber war game. It's time to step inside the cyber gauntlet.
Now, this wasn't just any old test. This was the Cage Challenge 4. A huge competition put together by defense agencies from the US, the UK, and Canada. The entire point of this thing is to push AI defenders to their absolute breaking point with super realistic, complicated scenarios. We are talking about the big leagues here.
And just get a load of this battlefield. This isn't one simple little network. Nope. It's a whole collection of totally different environments. You've got deployed networks, an HQ network, public access zones, all with different layouts, different sizes. The challenge was for the AIs to defend all these unique places, sometimes all at once. I mean, what a perfect place to test an AI that claims it can adapt to anything.
So the stage was set for an epic showdown. You had TERLA, the new, adaptable detective, going head-to-head against the old guard, the standard, brittle AIs that have to memorize every single layout they see.
And the results, well, they speak for themselves. This chart shows the defensive performance. Higher bar means better defense. You can see the standard AIs, the PPO agents, they did okay. But look all the way over to the right.
That's the single Terla agent using just one model to defend all those different networks. It was the undisputed champion. It didn't just compete, it absolutely dominated.
So just how much better was it? A single Terla agent was a whopping 69% more effective at defending the networks than doing absolutely nothing. To put that in perspective, the standard specialized AIs, they only managed about 58%. That is a massive leap in performance from one generalist AI that never had to be retrained.
But this is the part that really blows my mind. This chart shows how often each AI actually did something. The standard agents on the left, they're frantic, they're constantly busy, taking action about a third of the time. Now look at Terla on the right. It's barely doing anything. It only took a meaningful action about 7% of the time. It won by being insanely efficient. It's like a master detective who makes one single, precise move to solve the case, instead of a clumsy cop who tears the whole city apart looking for clues.
So yeah, this is so much more than just winning some competition. What we're looking at here could be the beginning of a whole new age of cyber defense.
This is basically a blueprint. A new way to build AI defenders that can actually protect a real-world, messy, constantly changing critical infrastructure, things like power grids, hospitals, financial systems, without needing to be constantly and expensively retrained. It's a defense that can finally evolve as fast as the threats do.
And this journey is really just getting started. The researchers already have a whole roadmap for leveling up Terla. They want to pair its smart mapping ability with all sorts of other AI brains, throw it into even bigger and more complex networks, and even see how it can team up with human experts, kind of like an intelligent partner.
All of which leaves us with a pretty wild final thought. I mean, if one generalist AI can already outperform a whole team of specialists across a bunch of different networks today, what does the future hold? Could we one day see a single, incredibly efficient AI, a true super adapter, defending our entire digital world all by itself? It's a powerful idea to chew on.